So I want to continue looking at integration by substitution. I'm going to do a couple of different examples here just to kind of solidify the process, but there's one of these actually that is a little bit different than the type that we've had to handle before, and it presents us with kind of an interesting opportunity, but also kind of a warning. And the warning is, don't just assume that all these problems are set up perfectly for you, okay? Sometimes students will be like, oh, it's in the textbook. It must be set up nice so I can just, kind of cruise through it without thinking about the process, right? So we'll get to that one here in a minute, but let's just work through the process here a little bit. I want everyone to really try to focus and think through these. I'm gonna do one, and then I'm gonna have you guys work on two others here, and then we'll look at the last one together. Okay, so just to kind of refresh our minds here, as we're doing the integral from x squared plus 1 squared times 2x dx, first of all, what would we define as u in this case? Yeah, the x squared plus 1. Okay, let's make u the x squared plus 1. So then we need to figure out what du is. 2x dx. Okay, don't forget the dx there. 2x dx. And do we have du, or do we need to do something to get it? Yeah, we've got it. Okay, we've got the 2x dx right here. So I'm going to rewrite this as, here's the u, so it's u squared du. All right, there's our du. Okay? So what's the integral of u squared? Okay, u to the third over 3. Okay, or 1/3 u to the third. Okay? At this point, remember, we didn't want the integral with respect to u, we wanted the integral with respect to x. So now we need to substitute that back in. Okay? And u is x squared plus 1. So it's x squared plus 1 cubed over 3. Okay?
X dx
Okay. So again, identify, remember this is kind of the integration version of the chain rule. It's not just a nice simple rule though, it's a process you got to go through. You look for the inner function though, the x squared plus 1, that's your u, and then find du so that you can do the substitution. Alyssa?
Can we do like find dx and plug that into that integral and then after continue?
Wait, can you do what?
So I get confused when we say 2x dx for du, but can I do like after we find du equals 2x dx, can I take that as dx equals du over 2x and put that in?
Oh, that would work actually. Yeah, if you made dx equal to du over 2x, and then when you substitute that in, you'd have u squared times 2x times du over 2x, and then the 2x's would cancel. If that helps you to think it through that way, that's fine. Sure. Yes.
If it is not 2x, if it is 3x, what will happen?
Oh, well, if it's 3x, remember we said if all you need is a constant to make the du that you're looking for, if this were let's say that it was a x squared plus 1 squared times 3x dx, okay? and we needed a 2x dx. What I would do on this case is I would take that 3, and I'd just pull the 3 out, okay, because it's a constant, so I could pull it out of the integral. I'd put the 2 in, and then I'd have to multiply by a half on the outside. Okay? So if you had the wrong constant, just figure out a way to make it the right constant. Okay? Or if you don't like, actually pulling the 3 out, if you left the 3 in and you say, okay, well I need a 2, I'll just multiply it by 2/3, and that means I have to multiply by a 3/2 on the outside. It's the same thing mathematically, but that's another way that you could handle that.
What's the constant is depending on? What's the constant is depending on?
The constant just depends on what you got for du.
I mean the y is 2
Why is it 2?
because the
Well, because we had the x squared here, so when we took the derivative of x squared plus 1, we got a 2x.
so if inside the square is like x to the 3 and plus 1, then the constant become 3.
Yeah,
Okay.
good questions, guys. This is I want you to think through these and think about, the different possibilities or the different kinds of things that you might run into. All right, that's really good. Okay, so at this point, we have these two. Both of them involve a little bit of trig. Okay, what I'd like, let's see. We have 3 rows. We're going to split into 2 groups, and I want you guys to kind of work on this together, work on these 2 together, see if you can get it, and then we'll see what answers you get. Okay? All right, so let's talk through the first one. All right, so they made u be the 5x, and du was 5 dx. Okay? And notice there's already a 5 dx there. Okay? So since there's already a 5 dx there, I'm going to put these together and make that, oh, that's a little short, and make that the du. Okay? So now I have the integral of cosine of u. Alright? And the integral of cosine of u is sine of u.
Wait, why didn't you put the? Oh, sorry.
Okay? Yeah, they made it cosine of u du. Cosine of u du. And then they took the integral, and that's that equals sine of u. And then they plugged the u back in. U is 5x, so they had sine of 5x plus the c. Okay? That's really good. Okay? Sine of 5x plus the c.
Yeah, I was looking at that one.
Oh.
I thought it was the same.
Yeah, it's just the same.
No.
Yeah, right.
Well, they were just doing yours after they finished theirs.
Oh.
So.
Oh, so they finished both ours and theirs.
You guys did have one a little bit more complicated. So let's look at that one. You guys made sine of 3x be the u. Okay? Sine of 3x. So you are looking at it as something squared. Okay? So the du, we had to use the chain rule. The derivative of sine is cosine of 3x times 3. There's our chain rule. Okay? And then we have a dx here. Alright, so if you look, you have most of the du here, but you're missing the 3. So you can see here they put a 1/3 on the outside so that they could put a 3 on the inside. And you can see how I wrote on the board here. Really what we're doing is we're multiplying by 3 over 3. And we put the top of that 3 3 over 3 is just 1, so we put the numerator on the inside, and we put a 1/3 on the outside. We're multiplying by 1, but now we actually can see this combined with this is the du that we're looking for. And then we just have the integral, or 1/3 times the integral of sine squared of 3x. Well, sine of 3x was u, so this is just u squared du. Okay? And then they took the integral of u squared is 1/3 u cubed. So we have 1/3 times 1/3 u cubed. And that's 1/9 times u, which is sine of 3x, cubed, plus c. Okay? So, good work. Good work. You're getting the hang of it. These are like a puzzle, but the cool thing is, it's kind of like they're puzzles that have different pictures, but they were all cut exactly the same. You do all these exactly the same way. The method is the same. Each one just looks a little bit different. Okay? The process is the same though. Alright? So let's now look at our final one. And this is the one that they throw a little bit of a curveball at you with. Okay? So this last one is a good reminder to us not to just assume that they're going to set it up real nicely for us every time. Alright? So let's start working through. What do we do first? Or what? Huh?
Rewrite it.
How would you rewrite it?
X times 2x minus 1 to the 1/2.
Okay. X times 2x minus 1 to the 1/2 dx. Alright? So now what? What's u? 2x minus 1. Okay, so then du would equal 2 dx, right? Alright, so I don't see a 2 in there. So this is where we're going to need to multiply by 2 on the inside and a 1/2 on the outside, right? Just like we did with the 3 and the 1/3 on that, on the previous example. Okay?
So you're still missing one.
But yeah, look at this. Now when we do the substitution, we have a 1/2 integral. We have a u to the 1/2, and we do have the du. Here's the du. The problem is, we didn't have anything to substitute for the x. And we can't take the integral as long as we have two different variables in here.
But x equal to u plus 1 over 2.
There we go. And that's the thing. Don't just automatically sub things in and assume and then forget that x. Just thinking it's all going to work out okay. Alright? And don't try to just pull the x out because it's a variable. It's not a constant. Alright? What we have to do at this point is substitute, but what we're going to do is add 1. That's 2x. And then I'm going to actually write it as 1/2 times u plus 1. And you'll see why in a sec. So now I had something that we couldn't integrate yet, but now if I substitute that in for x, I have 1/2 times u plus 1 times u to the 1/2 du. And the reason why I left it 1/2 times is because I could pull that half out now. Alright? So I have 1/4 integral of u plus 1 times u to the 1/2 du. Is that something we can integrate?
Yeah, but you have to do it again with the u.
What would we have to do? Oh, like another u substitution?
Or you could just multiply it out.
Wait, what? That's the way to go. We see something here, u plus 1 times u to the 1/2. Let's distribute that u to the 1/2. So that's going to be 1/4 integral of u to the 3/2 plus u to the 1/2 du. I'm just distributing this in. Okay? And that's the same thing we were doing earlier in the previous unit. When we were just starting with the rules. If you had something that you weren't able to integrate because it was a product or something, you just tried to simplify it to something that you did have a rule for. And now we have something that we can use the power rule for. Okay? What's the integral of u to the 3/2?
2 and divide by 5 times 2.
Okay. U to the 5/2 divided by 5/2 or times 2/5, right?
Why is it 5/2? Isn't it 3/2 plus 1/2?
Plus 1. Remember, you add 1 to the power.
Oh, I forgot to do that.
Yeah. So it'd be 2/5 u to the 5/2 plus, what's the integral of u to the 1/2? There we go, u to the 3/2 times 2/3. Okay? Now we can multiply by the 1/4, we can substitute u back in, and get our answer. So this is going to be, the 2 cancels with the 4, and that's going to be over 10. This one's going to be over 6. And that's going to be u, which is 2x minus 1 to the 5/2, plus u, which is 2x minus 1 to the 3/2, plus c. Okay? And that would be it. Okay? Any questions about that, or?
If I forgot to write C, I will lose point.
Yep. Gotta write plus C every time.
Can I ask you a question from last night's homework?
Yeah, does anyone have any question about this before we move on?
No.
Okay.
How the 5 comes in?
How the 5 comes in? Oh, well, when I multiplied by the 1/4, 2/5 times 1/4 is just 1/10. The 5 came from it, when I add 1 to 3/2, that's 5/2. Okay? So I add 1, it's 5/2, I divide by the new exponent, so it's divided by 5/2, which is the same as times 2/5. Okay?